Alright, so today we are going to look at the four problems from today's weekly contest 414. So the first problem, convert date to binary. We are given date in the format as shown. The first four digits will be the year. The next two after the hyphen will be the month and the day. So this will be the format as given in the constraint. So it's not going to there won't be any edge cases if we do it like this. So and uh, we'll extract the year, and that will be uh, zeroth position will be multiplied by 1000. But before doing that, we have to remove the you know it's a character, right? So to convert it into digit, we'll have to uh, subtract 48, if I believe that's the ASCII difference. And I'm going to add this four times. This will be only one position. One's position is going to have a weight of 1, and this will be 3. This will have a weight 10. This will be 2, weight of 100. This will be 1. And similarly for the day and the month, I will have only two of them, two expression, and that will be for the fifth position, because the fourth will be hyphen, isn't it? The fourth will be hyphen, the seventh will be hyphen, so this will be 5, 6, and for the day, right, this will be 8th and 9th, and I'm going to call a function that I will create, which will give me the string for each integer. That I'll call it integer to binary str year plus hyphen in between plus month plus hyphen in between plus date. Straightforward. Now I will create this function. Yeah, I'll call it num. So have a string answer. For each number, I'll get the bit from LSB to MSB, and at the end I will reverse it because I'll be appending it and the string, so I'll have to reverse it in the end. So while num is 0, it's not 0, it's greater than 0, then I will create I'll check if num, the LSB is 1 or 0. If it is 1, then I'll add 1, else I will add 0, and at the end I will divide it by 2, and I'll reverse it and return answer. Let's see if this works. Time complexity will be U of 1 because just a constant length in terms of in the string itself, and the space complexity will be O of 1. Alright, the second problem basically states that we are given a integer array called start and a d integer, and this together represents each element as an interval between start I to start I plus t, and we are asked to choose one element from each interval. So if we have 6, or if we have 2, 6, 13, 13, then 2, 7, that is 2 plus d, is going to be one interval, 6 plus 5, that is 6 to 11, is going to be another interval, 13 to 18 is another interval, 13 to 18 is another interval. So for each interval, we choose one value such that the minimum absolute difference between those values can be maximized, right? So basically, if we take this example and try to dry run on this, and if we fix this, all right, and d is equal to 5. So essentially, the intervals are 2 to 7, 6 to 11, 13 to 18, 13 to 18. And suppose I choose, you know, 2 and 6 and 13 and 14, suppose. In that case, or even 13 is fine. In that case, the absolute difference is going to be the minimum absolute difference is going to be anything. 13 minus 6, 2, 13, anything can be the difference, right? But if we want to make things easier, what if we sort this, right? That's our first hint. If we sort this, then our chosen element will also be in sorted order. It may not be in sorted order as well because we have overlaps, and we can choose a smaller element, but our difference is going to be absolute, so we don't need to worry about negative values. So essentially, if we sort this, our life is going to be easier, right? So suppose this is already sorted, so we don't have to worry about that. Uh, so here, if we choose, or if we try to think of in the sense of minimum absolute difference, then what can be its values, right? If we are given these intervals, right? So its value can be maximum of, if I choose 18 here and I choose 2 here, regardless of if it is possible or not, this can be the maximum, right? I'm saying if it's possible or not, that's because our minimum absolute difference can be anything, right? So right now, if we fix this to be the maximum absolute difference or the minimum absolute difference maximized, right? So that is going to be 16, right? 18 minus 2 is 16. But what can be the minimum value? Minimum value can be 0, right? If I select 6 here and in this range 6, then the minimum will be 0. So 0 to 16 is the range. And yeah, now that we have the sense of what we are doing a binary search on this minimum absolute difference, and we are trying to maximize it. So if I choose this as the range, my mid will be 8. My uh, if it's possible or not at this point, I'll check if it's possible. And how I am going to check that? I'm going to check that using this. So if 8 is the minimum absolute difference, then I have fixed the minimum absolute difference. So I can get the next value or a possible next value that is going to be 2 plus 8, right? It's have to be 8 distance apart, right? So 2 plus 8, 10, or anything greater than 10, greater than equal to 10. The next difference is, suppose I choose 10, right? Since 6 to 11 is the range, I choose 10 because that is falling within the range. So the next element is going to be 18 or greater than equal to 18, right? Which is possible. So I choose 18, suppose, because this is the only value that is falling within range. So 18 plus 8 is going to be 26, which is out of range, right? this is not within range, so it's going to be false. So it's not possible. So I'm going to go with a lower value, that is my end will be mid minus 1. So 0 to 8 is the range. So my end is mid minus 1. So 0 to 7 now it's the range. And this is nothing but 3. 7 by 2 is 3. So I'm going to check for 3 if it's possible. Uh, if I choose 2, my next value will be 3 distance apart, that is going to be greater than equal to 5. So if it's going to be greater than equal to 5 and 5 is not in range, then I'm going to choose the smaller element that is possible, that is 6. So it's still possible. So I choose 6. Next element is going to be 3 distance apart, that is 6 plus 3, 9. So greater than equal to 9. And I see it's not within the range, but it is smaller than the range. So I can always choose the minimum value, that is 13. Next element will be 13 plus 3, 16, which is within the range, so I'll choose 16. Alright, so it's possible. So now I go one step further, I'll go on the right side because it's possible, so I have to maximize it. Right, so 4, 2, 7 is the range now. 7 plus 4 by 2 is going to be 11 by 2, that is 5. Alright, so let's see if 5 is possible. 2, I select 2. Next is 7 or greater than equal to 7. So 7 is going to be the minimum one. I'll choose 7. 7 plus 5 is 12. Greater than equal to 12. So it's going to be 13. And 13 plus 5, 18. It's within range. So that's my answer. And yeah, I'll try for 6 now. I'll go one further and I'll see that I fail. And now beginning is equal to end, so my uh, so I have a beginning and end, right? So this is the beginning, this is the end. Right now at 6 it will be equal, and that's when I come out of the loop. So my beginning will be 0, or my start will be 0. My end will be what? So let's not forget to sort it. Start dot begin, start dot end. So this will be start dot back minus start, actually plus d, because we have to maximize this range, this end, and that will be the smallest element, that is start of 0. This is the range while beginning is less than equal to start end. We get the mid. Since we have this beginning and end as values, and if we look at the constraint, it's large values, right? So I'll have to, instead of doing beginning plus end by 2, I'll do it like this: beginning, or yeah, beginning plus end minus beginning by 2, right? So that it doesn't overflow. uh, if is possible, I'll pass you arguments in it. Or if it's not possible, then I will go on the left half. I'll minimize my answer, right? Because it's not possible right now. So my end will be mid minus 1. Otherwise, this can be a potential answer, this mid at this point. So I store it in an answer is equal to int minimum answer is equal to maximum of answer comma mid. Actually, I don't even need to maximize it, but even if we do, it's not going to harm us. And I'm going to go on the right side. So end or beginning is equal to mid plus 1. Finally, this is my answer. At this point, I will have a boolean for this method as a return type, possible or not. I'll pass uh, start, I'll pass d, I'll pass minimum difference, that is right now mid. So vector of in start, comma, this is the difference and this is the minimum absolute difference that we have fixed. Alright, so I have chosen something right at the start. I chosen the smallest element. So int chosen is equal to chosen start of 0. This is the chosen element. Alright. Uh, yeah, this is the chosen element. I start from the first index. Since this is the first interval, I've already chosen one element. So if I start from the first index, I is less than start size. At this point, I will check if start of uh, start of this index plus d, or actually just start of I, is greater than equal to chosen. If it is not, then return false here itself. Otherwise, at this point return true. At this point, chosen will be minimum of either chosen or start of I. Right? This is the whole thing that we are doing. So, in for example, if I choose, if I get 12, right? At this point, I got 12. In that case, uh, my answer will be 13, right? My chosen element will be 13 because I will choose the one that is within range and that's the smallest, right? So if I had 14 at hand, then I will choose 14 instead of choosing 13, right? Because that is the maximum value within range. So instead of choosing the minimum, I'll choose the maximum of chosen or start of I plus minimum absolute difference, right? So I don't need this, or do I? Yeah, actually plus d. Here it will be plus d start of I plus t if it's greater than equal to chosen. Then there is no way I can have a possibility here of forming the answer. So I return false here, right? Uh, actually, even if it's, yeah, this is good. Yeah, this is good. Chosen must not be greater than this start of I plus t. So this is good. At this point, I can just try running this, see if this works. Alright, there is some problem. Answer is equal to max of answer comma mid. I'll go on the right hand side. Uh, at this point, I'm choosing start of 0 and I'm checking if actually I should add this. Yeah, I'm actually choosing 2 and I'm checking for 2 plus the minimum absolute difference that I have fixed for the next range, if it is within or not, right? So chosen plus minimum absolute difference, or actually, you know what? Let me do it here itself, right? So I've chosen to, the next range that I am going to check is, or actually instead of chosen, I'll go with the name check, right? Check for this value, check for this value, check for this value. Alright, let's see if this works. Or actually, this should be also about. Yeah. Okay, so things are overflowing. 24. Since this is overflowing, I will. This must be overflowing. So let me make this long, and since we are checking against long, let me make this long as well. Now I think this should pass. Time complexity will be O of n log n here, n log n, okay. And the next thing is this one here. This can be, this will be in worst case O of n, isn't it? And we are doing it for every binary or every value that we see. So it's going to be O of n log n plus O of n log of uh, I'm sorry, this is n here, and this is basically a binary search on the difference, right? So log of d. So this is the range. It can go from, if you look at the constraint, it can go from 0 to um, 10 power 9, right? So this is the range. So overall time complexity will be O of n log n plus O of n log d. The third question, reach end of array with maximum score. So we are given integer nums and of length n, and this is straightforward. We are to reach from this point to this point, and every jump we make, the score gets increased by the difference between the index, that is 1, 3 will be just one difference, one index apart, and multiplied by the weight, and weight is going to be the uh, first positions value, right? Whatever the range is, whatever the jump is, from the starting point value multiplied by the index difference, right? So suppose this is the example. All right, at this point I will be here, and I want to reach here. I'm wanting to reach here. So answer will be, if I jump from here to here, suppose this will be the jump, and my answer will get increased by 4 into 2 is the difference, that is 8. If I jump here, my answer gets increased by 1 into 1, right? If I jump here, my answer gets increased by 3 into uh, 2, no, 3 into 1. This is the index difference. So my answer will be, for this possibility of jumps, it will be 8, 1, 3, and this is 12. But can I do better? Because in the question it said I want to maximize the total score. So yes, I can do better. In this, what we are essentially doing is j minus I into nums of I, right? What do we want to maximize? We want to maximize both of it, but which is going to be the dominant one? This is always going to be the dominant one, and this makes things a lot easier because suppose this was a 4. Here, let me take this example instead. This is better. Alright, at this point, I would want to go to the next greater element from 1 because this is going to be the dominant one, right? So if I choose this as the next greater element, I have a 3 as my answer. If I choose this as the next greater element, then it's not going to help me because I will have 1 as my answer, and here I will have 1 as my answer. If this is basically 4, 5, 5 as the score, but what if I would have gone instead of going to 1, I'll go to 5 directly, and this is going to be 2, and my total will be 9. Sorry, this is not 3 by the way, this is 1 because I jumped from 1 to 3 and my weight will be 1. So this is 1, this is going to be 7. That's how we are going to solve this. We are going to check for the next greater element. So we can use monotonic stack, but there is even easier way to do this. I'll have answer defined here. I will have the index, first index as 0. I'll choose to go from this point moving forward, and I will check if I'm sorry, uh, if my nums of index is greater than or is smaller than, which is this element is greater than my chosen element, then this is the chosen element. This is the chosen element. This is the current element. If it's greater, then I'm going to update it. I'm going to update the index. Before that, I'm going to update the answer, and that is going to be index I minus index multiplied by nums of index, and index now is going to be the current element, and that's going to be our answer. Suppose, like in this case, there is no next greater element, right? So I'll reach uh, beyond, so my this loop will break, right? Yeah, yeah, so this loop will break, so this case should fail. Yeah, this case is failing because I'm outside of the loop, right? So I have to add it here. My current index will be this minus 1. This is the current index, and my chosen index is index multiplied by nums of index, and that's only when nums of index is smaller than nums dot size Yeah, because if the last element is chosen, my index will be equal to the num size. Actually, I don't even need this because if it is equal, then the multiplication will be zero. The range will be zero, so nothing will get added. Right? Let's see if this works. Okay, it's overflowing at this point. Let me make this longer. This is space complexity will be O of 1 and time complexity will be O of 1, O of n.